Good afternoon, everyone, and thank you for joining this Community Care Smart Assistive Technology Collaborative for today's webinar. By way of introduction, my name is Anne Livingston. I've met many of you at many of our events and indeed hosted many of these webinars. I'm pleased to be the moderator for today's webinar, the focus of which is on blockchain. Our webinar today is facilitated by Global Community Resourcing for the Community Care Smart Assistive Technology Collaborative, which is a community of practice established several years ago and now has over 2,000 individuals collaborating on projects. And we're really pleased with the number of research and deployment projects that have resulted as a result of the collaboration that occurs in our collaborative. If you've joined us in previous webinars, you'll know that they are designed from feedback and requests we receive through our collaborative. Indeed, blockchain has been a item that's been discussed very solidly around our various forums and various groups. So we're really pleased that we've been able to bring this to you today. We also acknowledge the funding that we have received from the Queensland Government for this project, and we thank them for their ongoing support. Just a reminder, if you haven't already registered for the collaborative site, the details are now on your screen, and it is accessible and free to register. So I'd encourage you to do that. Please note that neither Global Community Resourcing or the Department of Communities, Disabilities, Services and Seniors are promoting or endorsing any particular product, research entity or organisation. Rather, the purpose of our webinars is to serve and to inform viewers of various smart assistive technologies currently in deployment or in development and being researched. We welcome questions through these webinars, but I will let you know that your microphones have been muted in the interest of the recording of this session. Your questions can be added to the question pane on your dashboard to the right of your screen. There will be an opportunity for all your questions to be answered at the end of the session, but at previous sessions we've been inundated with these questions, so the earlier you post your question, the more questions we can respond to. So today's webinar. In this webinar, Rob Hanson will introduce blockchain and the research that he has undertaken with CSIRO Data61. Rob Hanson is a senior research consultant and a futurist with CSIRO's Data61. Rob has worked in a variety of roles with the Australian government. He was lead author of Data61's blockchain report titled Distributed Ledgers, Scenarios for the Australian Economy over the Coming Decades. This is a really important piece of work and very unique in the landscape for evidence and research in this area. Rob has a master's degree in strategic foresight from the Swinburne University and also a master's degree in science from the Carnegie Mellon University. Rob is also a senior honorary fellow attached to the Autonomy Agency and Assurance, commonly known as 3A Institute, in the College of Engineering and Computer Science at the ANU. He works at the ANU working for the distinguished Professor Genevieve Bell. It's really a privilege to have you on board, Rob, and I'd like you to introduce your session today. Thanks, Rob.
Brilliant, thank you very much, and really a privilege to be here today. I enjoy talking about blockchain. I spent quite a while on that report with our crew looking at what this technology is and what it can do for everybody. And so I've been asked non-stop to keep talking about what this is, so the interest hasn't waned. So that's interesting to see. So today's presentation is my standard medium non-technical blockchain introduction presentation. it's a little bit different because I normally do it in front of people and I can see when their eyes glaze over and when I need to go back and repeat things or I need to move on. So please, if you have questions, write them down, and at the end we'll start talking about that. So today's presentation will be broken down into a series of parts. First of all, I'll tell you a little bit about who I am and how this all came to be. I'll then talk to you about what blockchain is in a non-technical way and try and get your head around that. I'll then talk about some of the implications around blockchain, what it actually means to have one, and so what that means. And then when we get to the end, I've got a visualization tool that we'll bring up, and hopefully by that time it should dispel all the myths and you should get a bit of an understanding as to what this stuff actually is and how it actually works. So I'll give you a metaphor to start with, but that visualization tool at the end I find really helps people understand and get their head around what this stuff is. So I do have a part halfway through the presentation where we talk about use cases and what it can do. So I'll talk to you in general times about what it can do. And when we get to the questions at the end, what I might do is see what types of things people are interested in. And then if we have time, I might go into a few other case studies that seem relevant to what you guys do as well. So I'm from CSIRO. If you hadn't heard of us before, we invented Wi-Fi. You're very welcome. And inside of CSIRO, I work for Data61. So Data61 is just a business unit inside of CSIRO. So we have about 1,200 staff. We've got about 450 students around the country. So we're the largest IT innovation hub in Australia. So we do all sorts of things with all sorts of people, with government, with industry, with universities, with all sorts of players. And we're mainly focused around IT. So I also work at the 3AI, or the as was mentioned before, so the 3A Institute, which is a new innovation institute at the Australian National University. Primarily there, I am working on assurance, and the idea is we've got all this data, all these algorithms, all this AI that is coming to the fore. People are using it, they're doing things with it. How do we make sure it's safe? How do we make sure it fits into a human-centered world? And so that's what we're doing. We're attempting to build a new applied discipline. So at the end of the 5 years of the Institute, we'll be able to have practitioners who are able to go out there and make sure that when we apply all this new technology, that it actually follows the law, that it follows cultural norms, that it does all the good stuff that it needs to do. And we're doing that underneath the distinguished Professor Genevieve Bell, who is an anthropologist who spent the last 20 years working at Intel, which is the place that makes all the computer chips. And she's just come back to the ANU, and we're doing that there. So an important disclaimer before we move on, please don't go out and buy any Bitcoin or any ICOs and say Rob told me to. This is a fair and frank discussion about what I found. So I'm a researcher in this space. This is what I researched. I don't have any, actually I don't have any cryptocurrencies myself, but I don't have any interests either way. I'm just going to let you know what we've seen and what we continue to see in the market and in our research. So I wrote the one on the left, the distributed ledgers book. We worked in tandem. There was a research team that spanned both of these pieces of research. It was done under National Innovation Science Agenda funding, which is essentially funding from the government. They said, we want to know about blockchain. What can we use it for? I was particularly focused and tasked with what can it do beyond the financial sector. We also had to look at the financial sector in that space, but we went well beyond that. And then I was looking into the future. Where could this stuff go? What could it mean? And so the one on the right, the black one, was more about what could it do today. So that's the more technical document. In there, you'll find that it discusses three major use cases, and it talks through the return on investment of the current technology as it stands at the time that we wrote it. And you'll see in there that, and as we go through the technology, you'll start to get a sense for the fact that it's quite burdensome to use this technology. It's got an overhead to it. You don't get anything in life for free. You certainly don't in technology. And to get the benefits of blockchain, there's a bit of an overhead at this particular point in time. So what's the story? What's it all about? What are we talking about? We're talking about productivity, and that's why people are interested in this thing. And particularly, we're getting productivity because there's trust. And we get that trust because of integrity. So what blockchain gives us, and we'll go through how it does this, but what it gives us is an ability to have integrity with information systems that we didn't have previously. And we can do that not only for data, but we can also do that for devices as well. So IoT stands for Internet of Things, which you may have heard about. So that's just talking about this trend where computers are becoming cheaper, network bandwidth is becoming more ubiquitous and accessible and cheaper. And so therefore we have all these devices out there which are connected to the internet, and they're sending all this data around the place. And so we certainly may be able to apply blockchain to both data and devices and get better integrity. And if we have integrity and trust with them, we can certainly see a lot more value and productivity coming out of them. So in a nutshell, that's really what it's all about. So why is trust so important? Well, this is a graph that comes straight out of the report. So this is one talking about trust in government. So when the people trust the government, what we see is that is correlated with higher GDP. So you can see that, where I'm looking, where's Australia, the yellow one, just underneath the red line. You can see over there that that's where we sit. So as per usual, the Scandinavian countries that everyone trusts and do all the good stuff are up to the sort of top right. And so definitely trust is something which is valuable in economies. It also helps when you can get trust between people. So when there's trust in society, that also correlates with increased GDP as well. So trust is a good thing. So let's break down what this blockchain thing is. And I have a spreadsheet metaphor for you. So most people know what a spreadsheet is. And so we'll use that as the sort of concept to discuss what this stuff is. But before I go into that, I'm just going to go back for a second and talk about where this all came from. So the internet as we know it today, it came from the Cold War. So essentially what happened was the US military decided we need a way of sharing information, because if a nuclear bomb goes off and it destroys critical infrastructure like a city or something, we need to get our information around that city to the rest of the United States so we can continue to do what we're going to do. And so they came up with essentially the internet. And it was really great. And at that time, it was only for people who were trusted. It was only for people who were part of that system. And so therefore, it was built around availability. It was built about how can I get this information to someone, given the fact that the network paths might fail, something might go wrong. And so I need multiple ways of getting this information around to them. So it's all about how do I get that information to them as soon as I can. So great idea, and then it started to slowly creep out into academics, into researchers, universities, and then before we know it, almost everybody and their dog was on the internet. But the problem is we don't trust them. So we've got this platform that was built in a trusted environment, all about availability, but then we went and let everybody on and we don't trust them. So we've got the situation where we've had to go and bolt in security. We've had to go and retrofit it and go, oh, how do we try and make sure that things are more secure? And that's been a challenge. And so that's one of the reasons why blockchain is really interesting, is because it's now providing integrity to people. And that's something that we didn't have baked into the system to start with. So I've often used spreadsheets for complex things that they really shouldn't be used for. So I used to be an enterprise risk manager, and I used to go, look, I would like to have some type of information system so I can go and aggregate all the information, get it all back from the people who are in the know, from the line managers who can report back, attest to whatever information they need to, and then I can summarize that, provide a dashboard to the executive, and you can look across that and compare apples with apples and make decisions about what we need to do. And then usually I get the response, well, can't you just use the spreadsheet? So I end up using the spreadsheet. And so it's not designed for text, it's really designed for crunching numbers, but people use them all the time for all sorts of things. Now, the challenge here is when I send those spreadsheets out to everybody to fill in, I don't know where they've gone. I've sent them out and they end up on thumb drives and laptops and network shares all over the place. And then when I try to recall them and get that information back, I have a challenge because I don't know who's updated what. Is there stuff that I've missed? There's a sort of gap in my vision as to what's out there with the current status of information. So that's a problem. So the idea behind blockchain is really we break it down into the two components. One is block and the other is chain. So if we just think of a block really as a spreadsheet, right? So we have a worksheet and it's formatted in a particular way. And what we're doing is we're collecting a whole series of transactions and putting them down onto a worksheet. And that is essentially a block. Now what happens is I enter a transaction. So I write my transaction and I throw it into the cloud. You write your transaction, it's formatted the same way because it's going into the same worksheet, and you throw it into the cloud. So all these transactions go into the cloud. And then after a particular point in time, someone comes along, grabs a series of those transactions, puts them into a worksheet, and then they lock the worksheet. Now, when they lock that worksheet becomes a block. Now, the way we do that is through some clever maths. We might talk about what that is at the end when I gauge to see how everyone's going. But really, that's the heart of it. We use some clever maths to lock a block of transactions. And then what we do is when we make our next block of transactions is we link the two of them together. So we always know the order of the blocks. And what we essentially get is a ledger that keeps growing in size, and we just keep adding more blocks to it. So it's another worksheet going on. You can think of it as another page going into a book, and we're binding a large book together, because back in the day, that's where this came from. There used to be ledgers, and people would go to the ledger, and there would usually be a keeper of the ledger, and so they would write in the ledger, and everybody could go to that point of that single point of truth, and they could see what the current state of the information was. We now have a distributed ledger because in this system, the people involved in the system get a copy of those blocks and they add it on to their own ledger or their own chain themselves. So if it's a public one, everybody gets the next block and they add it on, and so they can see all of the transactions that have gone beforehand. If it's a private one, so there's only a few people involved, then those people get that as well. So why did this come about? Well, it came about because of Bitcoin. So Bitcoin was the first instantiation or the first way that blockchain was used. And it wasn't built the other way. It wasn't built, hey, we've got this great idea about blockchain. What happened was the global financial crisis hit. Some people went, we don't trust the banks. Is there a better way to exchange value? And what had just happened was it had become cheap enough for people to be able to start to share this information around the internet with their computers running in the background to make the system work. So people were able to leave their computer running, and they were willing to let it mine and process some Bitcoin. We'll talk about how that happens in a second. So there was a price point, the network infrastructure was there. They went, great. We want to do peer-to-peer. We want to do what's sometimes referred to as disintermediated transactions. So we want to remove the bank, but we want to exchange value around the place. How can we do that? And so using the system that we just spoke about, they built the blocks that chain together. And what that provides for a cryptocurrency, and the cryptocurrency is a term used for a method of exchanging value that uses the blockchain. So for these cryptocurrencies, it provided them a leg up on what had previously been around. So previously there had been digital currencies, but at the end of the month or the reporting period, you always had to reconcile what had been going on. And it was easy to overspend and underspend, and we never quite knew where things were at. So with these blocks, now what you do is you write in the transaction and you say, okay, I'm giving my Bitcoin to Anne, and I'm doing that in exchange for something. And so that goes into the ledger. And so you can see, if I try to give my Bitcoin to you, that actually that Bitcoin that I'm trying to offer you, I've already given to Anne. So therefore, I can't give it to you. So it's an invalid transaction. So what we have is we have a global awareness now. We can see all of the information. We know exactly the provenance or the history of all of the Bitcoins. So we know exactly where they've been. So we know that, yes, it's legitimate. I'm the holder of this value, so I can exchange it to you. So it's a way of providing trust in a marketplace where we didn't have trust previously. Just while I'm on this too, sometimes people, there's two myths I want to dispel right now. Sometimes people think that Bitcoin is anonymous. It's not anonymous. You need an identifier to access the wallet and therefore the Bitcoins. And so it's called pseudo-anonymous. So you actually have an identifier there. It may not be in my name, but it's a way of working out who owned that Bitcoin. So not completely traceless. The other thing is the blockchain itself is what's referred to as tamper evident. So people talk about the fact that it's an immutable system and that once a block is written, it can't be changed, and that's correct. But what you can attempt to do is to put false blocks out there. But what happens is all the other people in the network go, well, that's not correct. And so they check it against their business rules and they check it against what they've already got in their ledger. And then they turn them down. They go, no, that's not right. And of course, in these situations, it's very easy to spot a bad actor. And when you have a bad actor, then you can sort of block them and say, no, we don't want to play with you. So Bitcoin was there to solve a niche problem, but really what's happened is now people have taken that concept and they've gone, that's really interesting. We can now get integrity in information systems that we didn't have previously. What can we do with this? This is really interesting. And so one of the things that, well, before I go on to that, one of the things that is another reason why it's so high profile at the moment is the fact that there has been billions of dollars in research and development, which has been spent in the last couple of years. I saw some figures the other day saying that $1.4 billion was spent in 2016 alone, just on research and development in blockchain. So this is not people buying Bitcoin or any other cryptocurrency. This is people investing in, this is an interesting idea. What can we do with it? And so what we're seeing here is the fact that people are investing in the technology and the people. So the technology is getting better, and I'll talk a little bit probably in a moment about how the Bitcoin stuff works. There are much better ways emerging about how that runs. And also the people behind it are also getting skilled up at the moment. They're being trained on how to do this and then how to apply that to real world problems. And we'll talk about some of that in a moment as well. So this is a leading indicator that whilst it's not commercial off the shelf at the moment, you can't just rock up somewhere and go, oh, grab that box off the shelf and get myself a blockchain and go and do things. It's coming. A lot of people are spending a lot of money. So just briefly, things like the ASX is spending a lot of money putting a blockchain solution into their new trading platform that they're putting in. So they've got a very large platform, it's a very large marketplace, it has very large stakeholders. They're putting a blockchain into the heart of that. It's a very pedestrian use case, it's very boring. And you probably go, why do you actually need that? But what they're trying to do is socialize everyone to go, look, we can use blockchain and it's safe and it does what it says on the box. It delivers as we're intending it to do, and then probably from there they'll go and build some further functionality on top of that. The other problem, and the reason that this sort of stuff is in the news at the moment too, is the fact that the value of Bitcoin has been all over the place. And so last year it kept going up and up, and people were saying it was, some people were saying it was going to go to $1 million of Bitcoin, and then it had the crash after Christmas, or actually just before Christmas. And I was just reading an article just now about how some traders are saying actually it's hit a death cross. That doesn't sound good. I'm not all the way through the reading on that, but it doesn't sound good. My point here is, and I won't go into it too deeply, but there are certain principles around how currencies work. So there are 3 of them, and cryptocurrencies don't seem to follow them. And I'm just going to put that into a very short nutshell. And that is essentially, if I was going to give you a Bitcoin and tomorrow it could be worth $1,000 more, $5,000 more, do I want to give it to you? And if tomorrow it could be worth $1,000 less or $5,000 less, do you want to take it from me? So there are questions there about whether a cryptocurrency is actually a currency. And also, one of the use cases that people often talk about is the use of Bitcoin and other cryptocurrencies in developing countries and those sorts of things, for things like microfinance and other things as well. With this sort of volatility, that's really quite interesting, because where we're talking about countries where there's a lot of poverty, they don't have much wealth to start with. These sorts of systems are probably not going to work very well in those situations. So cryptocurrencies, lots of questions about their use. So use cases. like I said, it's all about integrity. So unlike a standard database, so a standard database, you can update, you can delete, you can remove, you can do all sorts of things with them. And we did that for a variety of reasons. And that was primarily due to the fact that when our network started, they were expensive, they weren't very fast, we needed to get information around the place. And so we were able to do all these things with databases to get the information out there. So it was available, but we traded that off in terms of integrity. Now, what we've got is a potential solution here where we keep adding all that information together. So we've got it all there, but and what that gives us is integrity compared to what we'd have previously with databases. So I was a bit puritanical when this all started. I said it's not a database. You know, I've done all these degrees where I've had to do all this stuff with databases. It's not a database. Well, it's kind of a database if you want to think about it that way. But it's a ledger. You keep adding to it. You don't take things away. That's the fundamental difference between a blockchain and a database. So provenance, as I discussed, you can see where things came from. And so for Bitcoin, that's fantastic in any cryptocurrency because you know exactly where it's been. So you know that, yes, the person who has it now has that title. And so that's all good. And then transparency. So we can see everything that's going on. So that's useful in many circumstances, and we'll talk about some of those use cases in a minute. And that again, it depends on who has access to the blockchain. So there are different types of blockchains. There are some where everybody can see it and everybody can write to it. There's some where it gets a bit blended, so only some people can write to it, but everybody can see it, or only some people can write to it, only some people can see it. So there are different controls put in place depending on how you're using this thing. Now, disintermediation is the use case that everybody talks about, and they go, that's what it's all about. It's not where we're seeing the proof of concepts going. It's not where we're seeing the research going. It's really not where we're seeing the most value being played out. So yes, the original use cases, that's where it was. And so everybody started to learn this horrible big word and went, yes, that's what it is. But actually not so much. So the governments around the world, Georgia, Estonia, some of the Scandinavian countries like Sweden, which are using this, they're really using it for integrity. Places like Estonia are really using it because their infrastructure is under attack in a cyber security sense, and so they need to make sure that there's integrity in all their systems. So they're using it for those sorts of things there. And it depends also on how you configure these things. We'll talk a little bit more in a moment about, actually I might say that for the end, but I'll give you some use cases at the end to talk about why you would want to use it in different ways. That might be good. Okay, cool. So fundamentally, all about integrity. Yes, it can do disintermediation, but that's really not the main game. I'll give you a bunch of use cases when we get towards the end of the presentation. Okay, so one of the things that it can do really well is it can act like an oracle. So you put your information onto it, and it becomes a single point of truth. And then you can read from that, or everybody can read from that, and they go, yes, well, it can't be changed. And that's what it says. So lots of applications in that sense. We'll talk about a couple of them. And some of the benefits come from it is really easy to read from a blockchain. It's very trivial to read from a blockchain. It's harder to write to a blockchain. And we might talk about writing in that Bitcoin method towards the end of the presentation as well. So in 2015, the OECD came out and they said all these Internet of Things devices that I mentioned at the beginning, all these devices out there, if we have them in our environment, it's going to reduce the amount of arbitration and disputes. So for example, if I put stuff into a cargo container, into a consignment, and I send it overseas, often at the port of destination, what happens is someone goes, that's not what I ordered, or it's spoiled on the way, or it's less than I asked for, or whatever else. If we have all these low-cost sensors which are able to check to see if the air conditioning is working, check to see that the weight hasn't changed, that only authorized people have had access to it, or there was a camera trained on, or whatever else, and that information was able to be seen by everyone involved, then that will reduce the amount of friction, the amount of disputes and arguments about what's going on with this consignment. And so the OECD said, great, all these things will become an internet of trust. Now, there's another part to this which I don't think people necessarily realize, which is all these devices are going to start causing an awful lot of data to be created. So over the last couple of years, usually every year to 18 months or so, we kind of double the amount of information which is available to humanity, right? So the amount of information which is out there has been growing sort of at an exponential rate. And so when people look forward in their trend lines, they would look at a graph like this and they go, oh, okay, that kind of leads me out to the corner of the screen if I push that out to say 2025. Now I normally do this on an overhead projector, so it's not quite 75 meters, but we're talking a long way up. So if I was standing in front of you and I had a data projector behind me, we worked it out that then I would be needing to do the Al Gore thing with with one of those elevators and the cherry pickers to show you how much data there will be in just a few years' time. And people go, where did all that information come from? You know, there's the NBN, yes, I can only download so many Game of Thrones. What are you talking about? We're talking about all these devices, all this data flying around, because they're not just talking to people, they're talking to each other and all these things around the place. So what that means is that's great if we have all this information flying about. We've got all these devices out there. Yes, we can have this visibility as to what's going on. There's lots of use cases there that could be really useful. But the challenge is that we need to secure that information. The integrity of that information is very, very important. So if we could take the information of that consignment, so the goods that I'm sending overseas in that cargo container, if that information is being written to a blockchain and that blockchain stores it and I can see it and the other parties can see it and it's transparent and there's integrity, then lots of value is generated. So that's really, really good. Now, there is another problem with that though, and that is that trust is contextual. So people talk about, there's great trust, and there was that article in The Economist a couple of years back saying that blockchain is the trust engine. So the mechanism that is used to create Bitcoin and other cryptocurrencies creates trust. And it creates trust because it's a race. So what happens is those blocks I spoke about, someone grabs a whole bunch of transactions, and then what they have to do is solve a puzzle. It's like Sudoku. So they've got to solve a puzzle with those transactions. It takes a bit of effort to do that. On average, with Bitcoin, the puzzle is made, so we change it depending on how fast computers get. The faster the computers get, the harder the puzzle we make. On average, 10 minutes to solve the next block. In other things like Ethereum, which I'll show you a visualization of at the end of this talk, it takes a couple of seconds to do that. But the idea is, if we make you do this, and it's called proof of work and sometimes referred to as mining. So if you do this mining, we understand that you have to put all of your processing power into solving that puzzle to win the block. Because if you win the block, you get rewarded with an incentive. And in Bitcoin's case, you get some Bitcoin. In Ethereum's case, you get some gas. So you get whatever the cryptocurrency is to be part of this system. That means that you're not trying to game the system, because if you're trying to game the system, if you're trying to choose which transactions go in next to distort the market, or you're trying to put some fraud into the system or do something else, you are going to be slower than the other guys. And so it's a race to see who can put it together first. Now, it is an expensive system to run. So you might have heard of it spoken about in terms of a country, in terms of the amount of energy which is spent on all these computers around the world trying to mine the next block for Bitcoin. So I believe Poland is the current country that we're talking about in terms of the amount of power, or the equivalent amount of power that is being used by all these data centers around the world to put those blocks together. So that's historical. There's a lot of incentive for people to do that still. While there's still incentive in an economic fashion, I don't expect that to go away. However, it is very much like the early 90s when it comes to this in terms of the internet. So in the early 90s and the internet, there was rapid development. Lots of things changed really, really fast. When we're talking about blockchain, same deal. Some people have come up with some really cool ideas about how to do this, so you don't need to spend all that time and energy, but you can still have trust which is involved in the system. I might save that for the end if anybody has any questions. I would probably won't go into it now. So that's useful in that context when everything is on the chains, when everything is in that ledger. So we can see everything that's happened with all these dematerialized assets, right? So all these digitized tokens, which refer to Bitcoins, which live on this ledger. When it's all there, great, we get this trust because the system gives us trust, and we know because it's been running for almost 10 years and the maths checks out and everything's cool, that we've got integrity in that. You might have heard of things like Mount Gox and other places which were attacked and people lost stuff. It wasn't the blockchain that was hacked. That was fine. It's the fact that people had to, I was talking before about digital wallets. You need something so you can interact with the blockchain, so you can say, yes, that's mine. So what happened was they basically got hacked and their key got stolen. So nothing to do with the blockchain, has to do with their cybersecurity. So we all trust this. But once we start talking about things which are off the chain, so things which happen in the real world, then we've got a challenge there for trying to make sure that accurately is represented onto the blockchain. So it's not a case, it's not a silver bullet. You don't go, I'm going to throw in a blockchain and get trust now in a situation where I didn't have trust before. You can start to represent things and go, at a particular point in time, we wrote this down. And so you need to make sure that your real world processes are robust and they reflect what the actual state of the world is. So once that's written to the chain, that we have that integrity there, that it reflects the real world. So there's a bit of thinking that needs to go into this about the people and the processes involved. And when you do this, when you think about the extended process and the system involved, it may not give you 100% trust, but it might give you better trust than you had previously, and that might be enough. But usually what we find with this stuff is that it opens a doorway. You can start to ask good questions. When you couldn't ask those questions previously for a variety of reasons, now you can start to rethink your system. You can start to rethink even your problem statement and go, can we get better trust somehow? Is our information system giving us what we need? How do we get better integrity with our data? These sorts of questions are the types of questions we unpack when people come to us and they ask about blockchain, and we start to see good results, and the answer may not be blockchain at the end of the day. So some of the challenges now around blockchain, it's all very new. So we're working with Standards Australia right now on the international standards. And the first thing that we're doing is working on definitions. And we're trying to say, well, what is this language which is out there? I might go into some of the more peculiar things about the language later on when I bring the visualizer up. But suffice to say, people talk at cross purposes. One of the challenges that I was calling out in the report was there were a lot of technologists running around going, I have a smart contract that I'm trying to sell to someone because it's smart and it's a contract. And I would look at it and go, actually, that's not smart and it's not a contract. So no. And so I was trying to advocate for autonomous contracting tools and other terms that that might be useful to talk about what these things are, because really they were digitized processes. They did not digitize 800 years of case law. They often failed to take into account other things than the one type of process that could occur. So they went, here's when the sun is shining and everything is great, it happens like this. And I go, what happens if force majeure, whatever else, bad things happen? What do you do then? How does the person step in, press the red button, and go, whoa, hang on, that's not good. And so there's a lot of issues in this space. Look, there's a lot of snake oil in this space in general because it is so new. I have a lot of people who, and I sit down and go, okay, tell me about your thing. And actually at the end of the day, I go, hang on, I didn't actually hear the bit with the blockchain in there. Where was that? And there sometimes is not. And you've probably heard too, if you haven't, I forget how long, I think it was the last 2 years, they did a review in America of publicly listed companies, and the ones that inserted blockchain into their name, irrespective of whether or not they had blockchain technology. So like Long Island Iced Tea put block into their name and they increased their share price 3 times. So there's a lot of hype out there at this particular point in time. So what I'm about to tell you is some of the things you need to think about if you're getting involved in a blockchain and someone's coming to you and going, look, here it is. As I said, the standards haven't been written yet. The people are still being developed as to, who knows how to build this stuff correctly and well. Here's some things you need to think about if someone says, hey, we've got a blockchain solution, let's go for it. So one of the challenges, as I referred to previously, was the fact that these ledgers only ever get bigger. And so we just keep adding blocks to them. So in theory, that's good. But some of the challenges are the fact that when this all started, of course, and this graph goes right back to 1998, to get my decade right, 2008, when it all started. Then it was pretty small, and then it was a utopian situation. They were trying to say everybody can get in on this, everybody can let their laptop run and mine Bitcoin, and you can see all the ledger. Now, of course, it's concentrated in the top dozen or so miners in the world are the ones that win the Bitcoin because they have the biggest server farms, and the majority of those are over in China. So that's one thing which has taken sort of the democracy out of it. The other thing is the fact that this is so it's about 180 gigabytes in size now, is the size of the Bitcoin blockchain. So it's not really the size you can store on your laptop or your smartphone anymore and go, yes, I can see actually everything that's going on. You now actually have to pass that level of trust over and go, look, I am referring to such and such to give me that assurance that everything is fine. So there's a bit of delegation going on there. So you can get around this a few ways. One of the things you might want to do is think about the type of information you store in your blockchain. So maybe it's a content blockchain. So I write something to it. So let's say I'm a digital enterprise, a digital entertainment enterprise. So I put a movie on there. And I only put a few movies on there a year. And that's the majority of the transactions, but people come along and they read that, right? So we might put some access controls so they come along, and as long as they're a paid up member, they can read it, what's on there. So that's one way of keeping it small, and in a content blockchain where it's written to not very often, but it's read from a lot. It could be a transaction blockchain where we keep the transactions small, and they try to do that with Bitcoin. There's really not much going on those blocks. Those blocks are 1 meg in size each, and they store very little information. But you want to think about that. Does it scale? When I think about this technology going forward, as we've seen with other technologies, someone has a bit of a prototype, they try this, they try that, they had grand visions of going through a full software development lifecycle and doing all sorts of maintenance and updates. And in the end, it doesn't really happen, but it hangs around for 20 or 30 years, gets itself involved in something so it becomes a bit of a core system or a critical system, and we've got a bit of a situation there. Similar type of thing here. If we don't think about it, we could be in a situation where this thing starts to scale and grow, and it may outgrow the infrastructure that it was designed to live on. So we need to think about those sorts of things. So one of the other challenges is that proof of work concept that I was talking to you about, these puzzles that we have, that Sudoku type puzzle. You can, if you have a really fast computer, like a quantum computer, then all of a sudden those puzzles become trivial and there's no time involved in solving them. Now, that's a problem because we need that time gap to prove that there was a race and to make sure that people aren't doing bad things. Now, already we have examples of quantum puzzles that we can apply to the blockchain for when quantum computing comes online. So that's all good. But the challenge there is that we might be in a world of quantum haves and quantum have-nots. And so already if we're concerned about the fact that there's only a few miners in the world that win everything, we could find ourselves very quickly in a situation where only a few people have access to these really fast computers and everybody else doesn't. So the whole sort of idea behind Bitcoin being this utopian free-for-all has been eroded and is challenged by things like quantum computing, which is emerging. Another issue here is before, when I was talking about the different types of blockchains you might have, and I was saying that in the transaction one, you might keep the records small. So what you might do is you might keep metadata in there. So not everything about what's going on, but a little bit. And you might go, well, what I'll do is I'll encrypt that, right? So we don't want people to see that. So the information that I'm putting there, we want to control who has access to that. You might think, you know, I've got something and there's some privacy information, or there's something else. And the challenge becomes, well, if you've encrypted that at a certain point in time, and we're now 5, 10, 15, 30 years into the future, will the computers decades down the track be able to trivially decrypt that information? So a math genius comes along and says, hey, that cryptographic algorithm you're using to encrypt that information, I've worked out a way to make that half as effective. You go, ooh, okay, that's not so great. But then a really fast computer comes along, and so the fast computer and the hack of the encryption is put together, and then all of a sudden it's like, ooh, that's not good at all. So we need to think about the security of the information that we're applying and where we're sending the information to. Even if you think that you're protecting it, will that protection stand up in years to come, particularly if it's going to be something which is accessible to a lot of people? And in consortia, so if you've got a bunch of companies or organizations together and they want to share a blockchain because they want a single point of truth, great use case. Lots of people are talking about this. A lot of people are actually starting to do it. All good, but people come and go. And if they come and go, then there's a challenge there. And it might be that somebody has a legislative requirement to have access to your blockchain well into the future after they've left your consortia. And so if you didn't want them to see something and you thought it was safe, well, you know, there's potential down the track, but maybe not so much. So we need to think about how we're going to secure things and what we're going to put on these things and who we're going to give them to, which is really, at the end of the day, what we need to think about is governance. How are we going to govern this thing? And so here's an example of one of the areas we need to think about when it comes to governance. And this has already come to the fore recently. So people have said there is child pornography or links to child pornography on Bitcoin. So therefore, technically it's illegal. Should you be using it, should you have access to the ledger. So if you have something illegal written to the blockchain, if you have something which is classified written to the blockchain, or even just it's embarrassing and now it's FOIable because it's in a situation that people can get access to it, and you can't change that because it's written to the blockchain, we need to think about what we're going to do to govern this, right? So it's not just a technological piece. There's a broader system here that we need to think about. What is the business environment that this is sitting into, and how do we control that? So the public governance aspect, people often talk about the consensus model in things like Bitcoin, where everybody has to agree if they're moving to a new version of the software or doing something else. That's a problematic space at the best of times. But when you're dealing with several organizations trying to say how we're going to do this, you really need to think about what you're going to do there. Because what happens is, going back to my smart contracts example, you have situations where people will use the remedy at law afforded to them. So they might default on a contract and they might say, no, I'm not going to do that because it's now not worth my time to do that, right? There are very large contracts where this happens a lot because there's a small change in an interest rate, right? So there's a basis point change. People go, actually, it's better for me to default than actually to go through with the contract. Now, judges and courts come along all the time and they say that transaction was invalid, there was problems, and you need to roll that back as if it never happened. And we do that all the time now with databases. We change things and go, oops, no, okay, sure. The law has said something else. Let's change that environment. We need to think about how we're going to be able to do that with blockchain, where essentially we can do irrevocable transfer of title. We can write things in and they're indelible and they stay there. And that's the whole idea of a blockchain. What do we do then? So there's some people who've been thinking about things like this. I'll give a shout out to King & Wood Mallisons. They've written a really good framework called DNA, which is digital and analog. And the whole idea is if you're going to do something that involves the law, certainly automate things, but you need to be able to have that red button you can push and go, whoops, time for the humans to take over because the technology hasn't got it right? So we need to think about all this sort of stuff and how it works. So my 3 key points here are really... there needs to be cross-domain expertise. Normally I'm talking with auditors and accountants and lawyers, and I tell them, look, you don't have to understand this to be part of the conversation. So it's not just for technologists by themselves. we're dealing with a novel application of information systems here. And so there's this integrity, but there could be more integrity than what we're used to. And so we need to think through what the implications of that are. So integrity is what it's really all about, and that's fantastic, because if the challenge is we're in a world swimming in a tsunami of data and devices, we really want to have integrity and provenance with that so we can get the maximum value out of that sort of stuff. But then the challenges with all of that integrity are that we start to have issues with privacy, right? So as I was talking about before, you can start to decrypt things. You might have written something in, there was a whoops, and you go, well, what do I do now? There are some companies out there saying, hey, we can do things about that. But if you're starting to redact information, if you've got this ledger and we spent all this time and money putting this ledger together because we wanted to have that integrity, and someone comes along essentially with a big black pen and they go, right, I'm going to draw through this like it's a top secret document. So, we all agree that that shouldn't be there. So we take it out. Might be good for that particular point in time, but of course people change. And so when you get down the track and I'm looking at a particular transaction for a particular asset and I go, well, okay, I'm led to believe that this asset is in this current state of ownership and everything else. How do I know that that transaction which was blacked out back there isn't material to this particular asset that I'm looking at here? So there's a loss of trust in the ledger if we start to muck around with the ledger. And really, if we can muck around with the ledger, it's not really a blockchain anymore. So questions that need to be answered in that space. We really need to think through what the implications are and think about how we're going to manage those sorts of things. Cool. So what I've got now is I'm going to bring up a visualizer and talk you through that. So you've got a sense for what this blockchain stuff is, and then we might go to questions, and then I'll talk through some relevant use cases for you. So according to my stopwatch, I'm just on 45 minutes, so I think that's about right. So I'll just go through the visualizer, which you should have in front of you. It might be a bit jumpy, but essentially what we've got is a series of blocks, so the green and the red blocks, and that's the blockchain, essentially. So we've got the new blocks go on the left of the screen, and they're all joined together. And what you can see going on in the background is it's showing 500 of the 60-odd thousand transactions which are sitting out there waiting to be put into the next block. And so we've got different types. The blue ones are new contracts which are being set up. The yellow ones are contract transactions, and the gray ones are purchases. And so this is on the Ethereum blockchain. And so every now and then you'll see a bunch of them disappear, and they'll go into a new block which gets added to the end. Now there's a few challenges here that I didn't talk about before. One of them is you'll see the red blocks. Now the red blocks are called uncles, and what that means is they didn't make it. So what can happen is, because it's a race and you race to get your block in, and because it's a distributed network, one person on one side of the network can win a block at the same time as someone on the other side of the network can win a block. And eventually everybody gets a copy of all of this and they go, oh, we've got 2 winning copies. So it self-resolves, and it self-resolves by working out who is the longest chain. So if I win a block and someone else wins a block, and then someone builds on my block but they don't build on the other block gets discarded. And so it disappears, and all the transactions inside it go back into the pool, and they need to be added back in. So there's some challenges here. So people often ask me questions around, will Bitcoin replace money? Well, at the moment, it takes 10 minutes to make a block. Only so many transactions go into a block. It's the system itself is orders of magnitude slower than the Visa system for the credit card transactions around the world. And you are not guaranteed to get into a block anytime soon. There has been tremendous queues in the past. And when you do get onto a block, history shows us that you can't really be sure that your block is going to survive unless it's hung around for about 6 or so blocks. So in Bitcoin, that's about 60 minutes. So it's not really good for tap and go, because it takes a while for you to actually be assured that your transaction has actually happened and has been put onto the blockchain. It's going to stay there. So you might have heard of the term forking. So that's essentially forking. So The chain breaks, essentially goes in two directions, and then one of those directions loses, and that's the red one, and the other one wins, and that keeps going in that direction down there. Now, some of the challenges in this space is, of course, why would we use forking once when we can use it 3 or 4 times? And we do, and so that means a whole bunch of other stuff. And if anybody's got questions about that, happy to answer those questions as well. But I think what I might do then is open it up to questions, and we can go from there.
Thank you, Rob. That's great presentation. I just remind people on our board today to post their questions in the question pane to the right of your screen, and I see, Rob, many of them coming through. We've got one from Lucy, and Lucy's a provider in a remote community. And she's asking, what do you see the opportunities, Rob, for small to medium-sized organisations in this whole blockchain space at the moment?
At the moment, probably not an awful lot at the moment. What I see into the future is probably one of the ones which will be the most ubiquitous will be the use of blockchain in that Internet of Things that I was talking about. There's also a cybersecurity aspect that I probably won't go into too detailed about, but essentially when you configure a device that goes on the internet, that configuration is really important to its cybersecurity. And so if you have that configuration written onto a blockchain, and then you check to see if the device has the right configuration, then you know, tick, it's good, and if it changes, then cross, that's bad. So there's potential here for there to be quite a robust infrastructure in terms of the devices that you'll see. And I expect that that'll be probably out sooner rather than later. I was expecting a large corporate to release that last year. There is a fantastic resource called from the World Economic Forum. It was talking about the future of the financial infrastructure that came out in August 2016. It talks about potential use cases for blockchain when it comes to financial auditing and it comes to other things in that sort of corporate space. And when that takes off, I expect that that will be of fantastic value for small to medium enterprises as an anti-fraud tool. So all this stuff I was talking about in terms of integrity and provenance and transparency, really, it's a fantastic anti-fraud tool. And when that becomes available, that will be really, really good.
That leads probably nicely into our next question, Rob. I've got a question here from Claire, and she's a emerging young researcher in our space. And she's asking, do you think Wall Street will ever adopt blockchain, or do you think blockchain will remain as an alternative financial system?
I expect that what we call blockchain now will not be what we call blockchain into the future. So we're doing some work. So I mentioned that there was a scalability issue with the current proof of work systems. So Data61 is working with a university on a blockchain. It's been in the news, pardon me, and that is really, really fast. So there's lots of systems out there which are emerging, which could be very, very useful. In terms of a financial asset, there's a lot of speculation with these things which are called cryptocurrencies. They don't really act like currencies. They don't. So the three principles of a currency are a store of value, a medium of exchange, and that it is fungible. So essentially, you can move this thing around and trade and exchange with it. Not really so much in the cryptocurrency space. That said, I know, and a lot of that money that I was showing you before about the research and development came from the financial sector. I know that they continue to do research and things in this space. And so it's not necessarily about replacing money per se, but it's how do you create a ledger that can do better things down the track. And so I forget the figure, I want to say about 95% of the money supply in the world is dematerialized, and so it exists as zeros and ones on computers already. So why would you want to create another tool that just does that? That's not particularly useful, but there might be a lot of ways that this stuff could be used to create better integrity and transparency, and there's a lot of interest, particularly in central banks, to go, how could we use this? there needs to be a reason for why you want to apply it, and some countries appear to have a good reason for using it, and part of that comes from the fact that we want to have, particularly in developing countries, we want to be able to leapfrog the poles and wires. So a lot of places, you might have heard of a system called M-Pesa. You just use a standard phone, like a feature phone, like an old Nokia, and you can trade and exchange minutes of talk time on the network, and that's used to exchange value. And so they've really moved ahead. They didn't have banks, they didn't really have infrastructure, but they're able to use their mobile phones to be able to share money around the place, and that really stimulated their economies. Now, if we're able to do similar things but with greater integrity, we can start to potentially bank the unbankable, and that could be really, really exciting, and we can start to do a lot of interesting things there. So coming back to Wall Street, no, I know that they keep looking at cryptocurrencies. I don't expect them to really take that up. But the stuff that goes on under the hood, there's a lot of potential there for them to create systems which reduce friction and increase transaction speeds.
Thanks, Rob. Question from Doug, who's got a high interest in privacy and security. And in regards to security, Doug has asked, how do we minimise the human element, as this is obviously the weakest link?
I presume we're talking about situations such as the hacks of Bitcoin and cryptocurrencies in that case.
Yes, that's exactly.
Okay, yeah, so human beings are always the weakest link. So yeah, I'm a certified information systems auditor and a certified information security manager, and people are always the problem. Yeah, to go on a tangent from here, there are so identity is a huge challenge in the online environment, but a very underpinning part of how we do these transactions. And there's potential to use both hardware and software that incorporates blockchain to provide robust credentials, such that we don't need to worry about people providing passwords and those sorts of things to say, yes, this is me. Also, by the same token, there's a lot of interest in, is there potentially blockchain solutions that provide identity, so like in identity blockchains, that would help with the burden of anti-money laundering, counter-terrorism funding, identity checks. So at the moment, banking institutions are the custodian of a lot of your information, and they have to check that you are who you are, and there's a lot of overhead with that. There's a lot of talk of potentially blockchains creating robust systems that everybody can get onto, and therefore they won't have to spend as much money and do as much compliance. And when there's money and compliance and systems, there's always potential for loopholes and fraud and problems, and we saw the issue that happened with some of the banks that didn't go so well. So there's potential here to automate some of those processes through the integrity of the blockchain, remove the human from the loop, and fix up things when it comes to identity.
Great. Robert, I think we've only probably got time for one more question. It's just you mentioned that there is some work, good work being undertaken around governance frameworks, and you mentioned a particular resource. Are you able to detail that resource again, and we will post it for the members on the question pane who have asked that?
Yes, certainly. So it was some work done by King & Wood Mallesons, and particularly by their partner Scott Farrell. And Scott Farrell does work both in the blockchain space, and so he is on the Treasurer's Financial Advisory Task Force, I think it is, and so he was the blockchain advisory guy on there. He's also doing work on the open banking review at the moment, which is in the public domain. But yeah, they did a lot of work around a framework to think about how the law and blockchain intersect, and making sure that human frailty is taken into account. And the framework's referred to as DNA, or digital and analog, and that's available on their website, but I can certainly give the link to that after the presentation.
That's great. Thank you very much for your presentation today, Rob. It's been really an in-depth presentation to what is quite a challenging subject matter for some members of ours in the collaborative, and we look forward to discussing with you more some potential research projects.
Fantastic, that'd be great. Thank you very
Thank
much
you.
for having me.
And just by way of closing today's session, we've got a number of other events happening, including next week where, on the 4th of April, we're holding another webinar. This is a research project that has emerged through the collaboration and is involving some of our regional members via some researchers at University of Central Queensland and some of our international partners and national partners in our collaborative. We're very successful in gaining some funding for this project through the recent Dementia and Aged Care Services Innovation Fund. And the webinar on the 4th of April will be dedicated to talking about the research project, which is looking at innovative uses of technology, particularly in respect for caring for carers of people with dementia. So the registration link is on your screen and there will be further information on the site. For those of you who have joined us before on study tours, we're running another study tour into Singapore and Japan in July in conjunction with the International Congress on Smart Homes and Health Telematics. And more information is coming up and is available. So just let anyone know in our collaborative and we'll be able to get you some more information. So on your screen now is the contact numbers for our collaborative, and any of the staff here would be very happy to help you with information about upcoming events, study tours and webinars. Again, I'd like to thank Rob for his presentation today and also to everyone in attendance on this Easter Thursday. So I trust that you have a great long weekend and we look forward to your attendance at other events. Thank you.